width, petal length, and then the petal width. And then we have the species. Okay, so let's look at how to obtain the iris data or the iris data. So actually, before we can get the iris data, we need to log on to our console. I hope you can all see my console. Yeah, so this is my R console that I have over here. And then before we can log on to before we can get access to the iris data, first of all, we need to load a package we call the data set. So somebody will ask, what does this data set actually has to do with iris? Because you are talking about iris and then data set is coming in. So what does this data set actually has to do with the iris? So actually the data set is a package which contains a whole lot of, real world data that they've compiled and then they have actually added it to the R. So for the sake of practice, if you need to kind of familiarize yourself with R without going to get your own data set, you can use this inbuilt data set to work with. And they are all found in the inbuilt data set package. So we can have data sets like the iris, and then we have one we call the MT cars. I don't know, some of you are familiar, you are familiar with that one, the MT cars. It's also an inbuilt data set and it can be found in the data set package in R. So before we get the iris data, we have to make sure we load the package data set. And before we can load the package data set, we need a function we call the library. So library is just like, how will I even say it? In our normal education system, if you want to work on a particular task, you need information, right? So before you can have access to the information, suppose you are a student of the University of Cape Coast and you need to work on something. Before you can get information to work on that particular task, you have to do a whole lot of research, right? Or you have to conduct your own research. So this is where you kind of, okay, I feel like going to the library to read, right? So you go to the library and that's where you can have access to the information that you need. So the library function kind of work in that way. Okay, so it contains information that will actually help you to perform your task. So we need data set. Data set is the information that we need to actually have access to the iris data. Okay, so what you have to do is we have to use the function library. As you can see here, this is the function library. And it's a function because it's accepting an input and it's giving us what output, right? I can see that we have some mathematicians here, and then as a statistics student, you have some knowledge in mathematics like function, right? So the library here is a function, and then you can see that it's having an open and then a closed bracket here. That's where it takes the parameter. So the package we want to load is data sets. We call the function library, and then we type in data set. So as you can see here, this is the data set that we have package in R. Okay, you have to call what you call the library function. Okay, so the library is where the packages are stored. Okay, so the library is where the packages are stored. All right. Then we go ahead and then type library. So you type library, you open brackets, and then you close it. And then when you are done, I am using R Studios. So if I want to run, I'll hit the control and then enter. So immediately I press control and enter. That's simultaneously. When you come to the console down here, you can see that the code had been successfully processed. Okay. So if suppose I make an error here, let's say I remove the S and then try to run the code, you see that I'm having an error. Do you all see the error? So you can see that I'm having an error which is popping up here. Okay, so it means that there is no package called what? Data set. So that is the error message I'm getting. if the code is able to run successfully, then you are not going to see any kind of error message popping up. So over here, it means that the code has successfully processed. All right, so I'll continue. Now that we have been able to load our data set, we can now have access to the iris data. Okay, we now have access to the iris data because the iris data is found in the data set. All right. So you know that the iris data is having a structure, which we can see below in the PowerPoint here, 150 observation, 5 variables, which are actually laid down here. So let's go to our R studios again. That's our R console, and then try to look at the structure of the iris data set. Because I've loaded the data set, there is no need for me to kind of set the iris data to any variable, okay? Because the iris data itself is an inbuilt data. So far as I've called the package data set, automatically I can have access to the iris data. So you can see that immediately I start typing iris. Yeah, so you can see that immediately I start typing iris, our studios will automatically suggest something for me. So it means that the iris data is already accessible because I have loaded the package data set. Okay, so if I want to view this data set, there is a function we call the view. So you can see me saying function, function, function. So if I want to use the view function, in R, functions are actually having what you call the two brackets. Immediately you type it, the two brackets will automatically appear. That's when you are using R studios. But if you are using the base R, you have to type it yourself. So that's the flexibility of the R studios. So if I want to view the iris data, I just type the function view, and then I'll pass the argument iris. So immediately I pass the argument iris, I'll run my data. So control and enter. Okay, so I'm having an error here. What is the error? So view, seems, so could not find the function view. I think I made a mistake somewhere. So view. All right, so yeah. So I think I made a mistake in the first one, which I don't know where my mistake was. I think, yeah, the uppercase, it's sensitive to uppercase. I just used a lowercase. So over here, we can see our iris data nicely presented over here. You can see that immediately I passed the iris, there was an output. So the view is a function. Immediately I passed in an argument, it gave me an output. So the output is the iris data. So you can see the variables over here. We can see sepal length, sepal width, petal length, petal width, and species, as we have described in the PowerPoint over here. Okay, so that's on the view function. So you can just close the iris data, and then we have what we call the head. So if I want to view just some few observation of the data iris, I can use the head, and then the head will just give me the first 5 observation. So on your console, you can try it out. Head. So head is also a function. Okay. So head, and then immediately you type head. I don't want stress, so I'm using R studios. R studios will kind of give me the functions that I want automatically. Immediately I start typing, it will just pop up. But if you are using the base R, then you have to type it yourself. It's not having that automatic feature. So I'll suggest all of you should get the R studios. Okay, so head and then iris. So immediately I type iris, it will pop up because I have access to it, then control enter. So you can see that on the console here, I'm having the first 6 observations, right? So the head function is kind of going to give me the first 6 observations. That is starting from the top. That's from 1 to 6. So that is the responsibility of the function head. I can also get the bottom 6 observation. Okay. And if I want the bottom 6 observation, I'll use tail. So it's like head and tail. My head, my shoulders, my knee, sorry. So we have the tail here. So over here, the tail is kind of going to give us the last 6 observations. Okay, so you can also try that one out. Yeah, so as you can see, the tail is giving me the last 6 observations, which is from 145 to 150. All right. Then we move on to the structure. Suppose I don't know the whole nature or structure of the iris data. I want to know the iris data. What does it actually entail? What is inside the iris data? What are the variables inside the iris data? Okay, and then what are the values that this iris data actually contains? Is it just strings? Is it just numbers, or it contains both strings and numbers? So if I want to know that, I can use a function we call the STR. Actually, the STR stands for structure. So I want to look at the structure of the iris data. Okay, so for short structure, and then they've shortened it STR. So if you type STR, automatically, if you are using R Studios, it will just pop up. Okay, yeah, and then you pass in the data. The data you are working with is the iris data, and then we press Control Enter. So immediately you press Control Enter, we are going to see all this output over here. This output here is telling you that, yeah, the iris data is a data frame. So you can see data frame here, and it is made up of these particular columns: sepal length, sepal width, petal length, and then petal width with species. So you can see that the sepal length, petal width, petal length, and all those stuffs, they contain numbers. Okay, that's why you see norm, 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 norm. They contain numbers. That's why we have the norm, 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 norm here. Okay, yeah. And then the species, actually the species contain strange characters. I hope you are all familiar with strange characters, because I think you already have a previous session on R, so I presume that you have an idea on the strange characters. So the strange characters, we can call them factors, or there's another name for it, which I've forgotten. So over here, we have factors. Okay, they are just categories. Yeah, they are categories. Sometimes you can see CAT in some programming languages. They don't use factors. They use cats, which will tell you that, yeah, this particular variable contains strange characters. So the strange characters is what we have here. So we can see setosa here, and then vesicular here. So that is the species. The iris data, the species is having 3 factors, okay, or levels. 3 factors or levels or categories. That's the setosa, then the vesicular, okay, and then the other one is virginica. We will get to see those species very soon. Okay, so that is that about the iris data. Let's move on to the fun stuffs. All right, so before we analyze any data sets, okay, as statisticians or as aspiring statisticians, I know we have senior, statisticians among us, like our Dr. Empress. She is a senior statistician, and she knows a whole lot of stuff than we, the master students, and then the undergrads. Okay, yeah. So before you analyze any kind of data, you have to kind of assess the nature of the data. Okay, you have to kind of find out what are you actually working with. The data you are working with, how does it look like? Are there outliers? Are there missing values? Yeah. So you have to ask yourself these questions, okay? And we have numerical measures that we can use to assess all these questions that we are asking ourselves. And in statistics, all these kind of numerical measures or summary is what you call the descriptive statistics. So you kind of try to describe the nature of the data, okay, that you have. Yeah, so next on our list, that's what you are going to look out for. So we are going to look out for descriptive statistics. So we said descriptive statistics are measures that are used to describe and summarize data. This one we are familiar with all these things. Yeah. So we are going to look at some few, summary statistics or some one or two of them. We are not going to take all of them into consideration, sorry. Just some few. So we are going to consider the summary function, the mean function, the variance function, the maximum, and then the minimum function. So basically, we are going to limit ourselves to some few functions when it comes to descriptive statistics. So we are going to hop onto our R console, and then we'll try to perform all these functions on our studios. So as you can see, we have the mean function, okay? Before we can use the mean function on a particular variable, we have to kind of know the type of variable we are working with. So over here, we know that the iris is having 5 variables, and each variable actually have its own type. So with the iris data, the variables, I think 4 of them are actually continuous, and then the other one, which is the species, is categorical. So if you want to run the mean function, normally the mean function deals with continuous variables. So if you want to run mean on any particular variable, you have to ensure that the variable we are working with is continuous. So over here we have the sepal length, which is a continuous variable. Okay, so as you can see, looking at the syntax here, we have the mean. Because the mean is a function, that's why we have 2 brackets here, and then it is taking on some argument, and the argument is taken over here is the sepal.length. So why do I have this $sign here? Why do I have this $sign here? Can someone just quickly answer me or have an idea on why we have the $sign? Anybody to share?
Is it representing a data structure?
Not really. Not really.
All right. So
Yes.
I think the $sign helps us to pick a particular portion of the data set we are having. So we are using the $sign to be able to pick only the sepal length from the entire variables we are having.
Great. Yeah, that's what I wanted to hear. Yeah, that's good. So over here, we can see that the iris we are having, when we looked at the structure, let's come to the head. Good. So over here, we can see that we have sepal.length, sepal.width, petal.length, petal.width, and species. Okay, so the iris is a data frame, and it's actually having 5 columns. Okay, yeah. So if you want to access a particular column, then I can say, hey, our studios, I need iris. Okay, but then I don't need all the columns. I just need only this particular column, which is the sepal length. So the $sign is kind of trying to give a specification, a direction to R that, yeah, go to iris data. This is the particular column that I want. I want only sepal.length. So that's the function of the $sign. Yeah, so that's what the dollar sign is actually doing over here. So it is telling out that I want you to find the mean of sepal length in Irish data. So when you put the dollar sign here, R is going to go straight to sepal length, which is in Irish data, and then find the mean in there. There are so many ways in doing that. We also have another function we call the attach function. Okay, you can also use that to access the columns. So instead of using the dollar sign, okay, let me just demonstrate this one. When I'm done, we use the attach function as well, and then we see how it also works. So over here, I'll just run this line of code here, which is what I've highlighted here. So after running it, I can see that the output is being presented right in my console. So over here, we can see that I have 5.8433. So this 5.8433 is the mean of the sepal length, is the mean of the sepal length. So if you are on your RStudios, just try to do that of the petal length and let's see. Let all of us try it out. Let's find the mean of the petal length. I just did that of the sepal length. Let's try and find the mean of the petal length. So if any of you have it, you can just say it and then I'll try it on my screen here and we'll try to verify. Is any of us there?
Um, 3.758.
Okay, so Ben is saying 3.758. Let's verify and see. Is anybody having different answer from what Ben is saying? Hey, our ladies, it seems you are not talking. Please, this program is not for us. So that's why we have. Let's try and verify what Ben just said. So I'm trying to find the mean of the petal length. So I'm telling R, I want you to go to Irish data, Irish. And then when you go to Irish data, I want you to find the mean. So single out the, so you see that immediately I typed, RStudios is very kind of flexible. Immediately I typed the dollar sign, you see that it's giving me suggestion, okay? So it is telling me that in Irish, you can have sepal length, sepal width, petal length, and petal width, okay? And then species. So immediately I typed the dollar sign, you can see that R is suggesting the columns in the Irish data. Okay, so we are interested in the petal length. So I'll just hop onto the petal length and then I'll run my code. So yeah, after running my code, I'll go to the console and then I'll see the output of the code I just processed. So this is the code I just ran, and then on my console, I'm having the output there, which is 3.758. And I think that's what Benjamin just mentioned to us. Okay. Then let's look at the attach. Instead of you, maybe you might kind of find yourself wanting with the syntax. Okay. There is a way you can have access to the columns without trying to use this dollar sign, iris, dollar sign, petal, dot length. You might even forget. Okay, so there is a way. There is a function called attach. So if you use the attach, what the attach do is that it's kind of let you have access to the columns within a particular data without specifically calling the data and then using the dollar sign to single out the specific column that you want. Okay, so if you use the attach, you just, because it's a function, just attach and then you open bracket and then you type in the data you are working with. So I'm working with iris and then I'll put in iris and I'll run. Okay, when you run the code, you will not see anything. You will not see anything. But what you've done is that you have instructed the system that it should try to unmasked. What I mean by unmasked is like within the iris data, the columns are actually hidden. Okay, so you are trying to tell out that, okay, I don't want the columns to be hidden anymore. I want them to be exposed so that I can access them directly without always calling iris within what I'm trying to do. So over here, I have access to the columns since I've used the attach. So now that I've used the attach function, I can have access to the columns. So if I want to find the mean of the sepal length, I don't need to type mean and then, mean and then I don't have to type iris again. Mean and then I'll start. I want the sepal. So you see that immediately I type the sepal.length, I can easily access it. Okay, I don't need to go and type iris and then try to bring some $sign somewhere before I can access the sepal length. Okay, now the system has actually exposed all the columns within the iris data. So I can easily access the sepal length without the $sign or without the help of the $sign. So I'll run my code and you can see that I'm having the same result, okay, as the initial one that I did. So this is the initial one that we did, and then this is the later one that I just did. Okay, so I have mean and then sepal length. This time I don't need the help of the $sign. So that's another way that you can actually kind of alternatively write your code, okay, without the help of the $sign. Okay, so let's move on to the variance. Okay, so the variance, if you want to find the variance of a particular variable, the variance function is what you are going to use. So over here, the variance function in R is var. Okay, it's just var. And remember, for functions, we don't need to kind of load them. Somebody will ask, why is that we can easily say mean, we can easily write the variance, but when we needed iris, we had to go and load package before we get access to iris. For mean, variance, and all those things, they are functions. Functions, they're already, built within the system. Okay, for them, there is no need for you to go and load any package. They are called default packages. They are inside. They are incorporated in the system. Okay, so you can easily access them anyhow without loading any package. All right, so with the variance, similar to that of the mean, you just write var and then whatever column or whatever variable that you want to run the variance on, you just put it inside the open and close bracket, and then you run your code. So immediately you run it, it will give you an output. So this is the output for the variance. I hope you can all see this is the output for the variance. And this is what I did. var and then iris $sign sepal length. That's what I've done. So I said R, go to iris, locate sepal length, and find the variance of sepal length. And also bear in mind that if you want to find the variance of a particular variable, ensure that the variable is what? Continuous. I hope you are all familiar with continuous variable and then categorical variables. So you can use the variance function on a categorical variable. So we should take notice of that. Okay. If you don't want to use the $sign, you can still go ahead and say variance sepal.length. It will come. If you've used the attach, you can just simply go variance, then sepal.length without using the $sign. It will also give you the same response or the same output that we need. Okay, then let's look at the median. Okay, we also have the median function. So the median function is also written as this median, and then you open bracket, and then you run the code. So we want the median for sepal length. So we have median, and then Irish $ sepal length. So when we run it, we have our median. You can also alternatively, without using the $, just write median open bracket sepal.length and close it, because I have attached the iris data, so I can easily access the variables anytime I want. Okay, so you see, when we're doing the mean, the variance, and then the median, we kind of did them systematically, took them one after the other. There is this interesting function called the summary function. When we hit the summary function, or when we use the summary function is going to give us the whole, summary of the iris data, including the sepal mean, the petal mean, the sepal width, the petal width, and all other variables over there. So we have this interesting function, which is summary. We just type summary. It's also a function. That's why you see the open and close bracket. And then we pass in the entire, this time we are passing in the entire, data set over there. And then it will give us a summary statistics. So it is going to give us a summary of the entire data we are working with. Okay, so let's look at what the summary is capable of doing. So over here, you can see the output here. So you can see that the summary is even going ahead to give me the minimum, the maximum, the upper, what do you call it? Sorry, the third quartile, the median, the first quartile, right? Yeah. So as you can see, it is giving me minimum, the first quartile, the median, the mean, and then the upper quartile or the third quartile or whatever it is, and then the maximum, right? So we can see all that over here, and you can see that it is doing it for all the columns, all the columns, all the columns. So there is no need for you to single out a particular column and then try to mean sepal.length like what we did initially. So over here, when you use the summary, it's just going to give you the summary statistics of the entire variables within the iris data. And you can see that it is doing same for the species. Over here for the species, you saw that it didn't calculate the mean, the median, and it just gave us the total number of observation in each of the species. So the species we have here, there are 3 species, the Setosa, the versicolor, and then the virginica. So each of them is having 50 observation. And you didn't see mean, median, maximum, minimum over there. Okay, why? Because the species contains what? Categorical variables. Okay, and the only thing the summary function can do on the categorical variable is to give us the number of observation within each of the categories. It will not be able to find the mean, it will not be able to find the median, or find the maximum or the minimum. Okay, so that is that about the summary function. Let me go back to my PowerPoint and let's see what you have. Okay, so you can have access to the demo codes and you can try them out yourself. So next on our list is the visualization in R. So now that we have been able to describe the data as part of the data description, that's we have been able to describe the data using numbers, right? Numerical measures. So this time we want to also we want to describe the data using visualization instead of mere numbers. Okay, so over here we are going to use some charts to try to just tell some story or try to visualize what is going on within our data set. Okay, so we are going to limit ourselves for the sake of time to bar chart, histogram, and box plot. We are not going to dive deeper. There are other plots like bar charts. We can have what you call heat maps, correlation charts, and all these things. We even have what you call the violin. I saw this particular chart. Is a violin something something? I'm forgetting the name. There are a whole lot of charts nowadays. We even have donut charts. Yes, donut chart, pie charts, whatever it is. Yeah. So we are going to just focus on bar, chart, histogram, and box plot. So let's look at how to demonstrate those charts using the our studios. Okay, so over here, we are going to focus on the bar plot. So how do we get a bar chart from our console? So this is the demo code. You can try it out. Let me go to my our studios. Yeah, so the demo code is over here. All right, so over here, what are you going to do? We are just going to do what you call bar plot or bar chart. So if you want a bar chart in R, or if you want to create bar chart in R, the function you are going to use is bar plot. We are going to use the function bar plot. There are other ways to get a bar chart. We have this package we call ggplot2. It also have its own way of getting a bar chart from it. So we are using the base function, which is bar plot. Okay, before we can get the bar plot, normally we do bar chart for categorical, what do you call it, data, okay? So that's why we have the species here. Yeah, so, but before we can plot the bar chart for the species, we have to first of all convert it to table. Remember over here, the species, what do you see? Over here, we only see what you call Setosa, Virginica. They are strange, variable characters, okay? They are all strange. And before we can construct the bar chart, we have to get the number of observation in each of the categories. Okay, yes. So that is why we have our table here. So what the table is going to do is that it's just going to tell R that, okay, because I need, excuse me, sorry. Yeah, so because I need to construct a bar chart, I would like you to get the observation for each, the number of observations for each of the categories. Are you okay? So that is what this function is doing. So it's kind of going to give us a table. So let me run it. And I'm not sure it's going to give an output. Yeah, good. It's giving us an output. So just like the way I was saying, it's going to give us the number of observations under each of the species. Okay, that's what the table is going to do. So that when we are going to plot the bar chart is going to use the values over here as the count. Okay, it is going to use it as the count, and then the categories will be on the x-axis. So if you don't do that, and then we go ahead and put in the species in the bar plot, you are going to get error. So suppose I don't convert the species into table, and then I go ahead and say bar plot. Okay, so yeah, so bar plot and then species. So you see that I'm having an error. Okay, you'll be like, why am I having an error? Species is already there. Okay, so look at the error function that is given. Height must be a vector or a matrix. You get it? Height must be a vector or a matrix. So it's because we have to first of all convert the species we have here. The species is just a single column. But before we can plot a bar graph, we need, this one is a matrix. As you can see, it's a matrix. It is a 2 by 3 matrix. So we have 3 columns here and then 2 rows. Okay, yeah. So you have to use the table on it first before you can find the bar plot. Okay, so let me clean this code here because that's not how we do it. So you need to convert it to table, and then you kind of put it in the bar plot function. All right, so let's come to the bar plot itself. So over here, if you kind of put it in a table form, that's not it. you can't go down and then go and write, oh, because I've done the table form, I can just go ahead and put the species inside. No. Okay. We are doing the bar plot for this whole thing, the table that we just saw. Okay, this whole table. Okay, so this whole table is a matrix. That's what you are going to pass into the bar plot. So if I run this code here, you can see that we have our bar plot. I hope you are all seeing it. Yes. So this is our bar plot. You can see that our bar plot is nicely generated here, and we have 50 observations for each of the categories. All right, so let me close this. I don't know, the next time that you have a meeting, I don't want to stress much on the bar plot. You can actually make it attractive, change the color and all these things. We call them CS. You can add some arguments and other stuff to it to change the color of the bars and all these things. But because we don't have time, let me quickly move on to the next thing. Okay, so that is that on the bar chart. When you go try and watch some YouTube videos, it will give you an idea on how to change the color, and then you can do a whole lot of stuff on this bar chart. Okay, let's move on to the histogram. Okay, the histogram. So over here, for histogram, we normally construct histogram for continuous variable. Okay, yeah, continuous variable. So we are going to limit ourselves to the sepal length. So we are going to limit ourselves to the sepal length. So we are going to construct a histogram for the sepal length. All right. So let me try and run that one, and also let's see. Okay, so over here you can see that I have constructed a nice histogram for the sepal, and that's this code. Okay, this code. And normally plot does not appear at the consoles. You might be asking, why is it that when we run code, it actually appears at the console, but this time around, when we did the plot, it's not appearing at the console, but rather it is appearing at the plot side. So this is the plot side. This is where graph actually displays. So you can zoom in the plot as I've done here. So this is the histogram of the sepal length. You can change this title, and then you can change the title over here at the X side, and then you can change the main title. So if I want to do that, I can add some argument to this function, which is main. There is this main argument, and then I'll try and say, okay, so main is the title. So if you say main is actually, you are trying to tell out that I don't want the title to be histogram of iris sepal.length. So I want it to be in this form, histogram of sepal length. Okay, so this is what I want it to be. And then I don't want the x-axis, so I can say x label. Okay, so x label, that's how you call it. So x label, so immediately I type x label, it will come x label equals. Okay, so over here, my x-axis, okay, is the species, and then the y is the frequency or the count. So I want my x-axis to have the label sepal length, not iris $ sepal length. So I'll just pass sepal length. And then let's say I want my y label not to be, so I'll say y lab or y label. Okay, y lab stands for y label. So I want my y label to be, let's say, the length, or let me say count. If I use count in some way, let me say length. It's actually a string, so length. All right. Then let's run this code and see what will happen. So you see, immediately I run the code, you see what is happening. Now I've changed the labels. Okay, so now you can see histogram of sepal length. You can see my Y label having length, and then my X label having sepal length. Actually, the J is missing, but I hope you guys actually you have seen what I want to demonstrate. So yeah, so you can add a whole lot of arguments to the histogram. You can even overlay what you call the distribution curve on it, a normal curve. You can overlay that on it and then change the colors of the bars and all these things. Yeah. So let me move on to the next thing, which is the box plot. So the box plot is also another visualization tool that we can also use to describe a data. So before we can plot box plots, we need two variables. What variables do we need? Who can tell us the variables that we need if we want to plot a box plot? Are you guys here with me? Anybody want to share with us? Hello? Hello? Construct a box plot. You will need two variables, okay? And I want to ask, what two variables do we need before we can construct a box plot? Okay, let me answer it myself. Yes.
I don't know whether
If
they
you
are
want to answer it,
available.
hello?
Hello.
Yeah.
Please, I don't know whether to put them as variables or, but what I've learned, you need your lower quarters, your median, upper quarters, and minimum
Oh,
and
okay.
maximum.
That's when you are drawing it with your, like, you kind of using your manual way to draw it, right? But we want the system to draw it. This time around, we don't want we don't want to do it manually by finding the lower quarter, upper quarter, the median. We want the system to give that to us.
Okay. I
Yeah,
don't
that's
know
what
that
I
one.
mean. Yeah, that's what I mean. Yeah, okay. So before we can plot the histogram, okay, I'm sorry, the box plot, we need, you can actually plot or do the box plot for just a single, variable, okay, like the sepal length. But what I'm trying to say here is that if, you see, when we're if you want to plot a scatter diagram, you will need two continuous variables. Okay, maybe the way I frame my question, that's why. If you want to plot a scatter diagram, you need two continuous variables. Is that not the case? If you want to plot a bar chart, you need a categorical variable. Okay, so in which case when do we plot a scatter diagram? That's what I'm trying to ask. So if you have a continuous variable and a categorical variable, okay, you can plot a box plot for these two variables that's combined. Okay, that's what I was trying to ask. But you can just plot a box plot for a single variable like sepal length. You can just take the sepal length, that's one continuous variable, and then you plot a box plot for it or do a box plot for it. Okay. So my question was, if I have a continuous variable and then a categorical variable, I can construct a box plot for it. Okay. Yeah. Sorry. So over here, let's see. We have the sepal length and then the species. So we want to construct a box plot for each of the species. Okay, but then we are going to look out for the sepal length. So if you consider setosa, we want a box plot for setosa, but then we are much more interested in the sepal length. Okay, so that's what this code actually stands for. So box plot is the function, and then sepal.length. I want to find a box plot for sepal length, but then I want it for each of the species. So this symbol is what we refer to as the tilde. Actually, you can find it on your keyboard. It's there. I think it's the first key. I don't know, on my laptop here, is the first key. That's on the numerical keys. Is the first thing you see. Yeah, it's called tilde. So what I'm trying to say is that I want to construct box plot for sepal length, but then I want it for the species. Okay, so this symbol here is kind of telling us that I want you to plot a box plot or construct a box plot for the sepal length, but then in relation to the species. So it's going to consider each of the species, and then it will plot a box, or it will construct a box plot for each of them. And then over here, they are just arguments. What I have in here, this is an argument. I'm telling the function that it should use the data iris. Okay, so the data argument is telling me that go and use the iris data. So go to iris data, take sepal length, plot the box plot for each of the species. Okay, and then the main here, you've seen it before, is just going to give a title to the box plots. Okay, so let me run it. So as you can see, if I run this piece of code, this is what I'm going to get. So you can see that the code that I just processed is giving me this nice box plot. And then you can see that the main over here, the title here is box plot of sepal length by species. That's what I have in my main here. So over here, you can see that I have what we call box plot of sepal length. Okay, yeah. So that's what is displaying nicely over here. And then you can see that I have box plot for each of the categories, And this one, if you visualize it, there is no need for you to go to the entire data, and then before you can know that, yes, Virginica is having the highest sepal length. This box plot here is going to show you that, yes, based on this box plot, we can see that Virginica is having the highest sepal length. And you can see that on average, yes, still Virginica is having the highest. And then we all know what box and whisker can do, right? We know what it implies, and then we know its properties and its features, and what each of the feature we have here actually tells us. My job is to show you how R can actually do the box plot for us. Okay, so I can also decide to do box plot for sepal length, to look at the average sepal length, the upper quartile, lower quartile. So I can also say box plot. Box plot, and I'll just pass on the length, sepal length. Yeah. And then there is no need for me to do. I can easily access sepal length because I've attached it. Okay. So over here, I didn't specify the data. Okay, you know why I didn't specify the data? I didn't specify the data because I've already attached. Similarly, in the first one, I can decide not to specify the data. It will still work because I've attached the data iris. So I can easily access the variables directly. Okay, yeah. So this is what I'm talking about. I can just do a box plot for a single variable. Yeah. And then we can do same for when we have more than two variables. That is a continuous variable and then a categorical variable. Okay. So you can try it on your own. Okay, so what do you have on our list? Please, when my time is up, just alert me so that I can